Here we would like to explain the corrosion science basics. First, let us understand what is corrosion. Corrosion is nothing but deterioration of materials by chemical interaction with the environment. The term corrosion is sometimes applied to degradation of plastics, concrete, wood, but generally refers to metal. Now, let us go for metal corrosion. Metal corrosion, the destruction of material by chemical or electrochemical reaction to its environment. Typically, this involves the transfer of electrons, or we'll call it as an oxidation reduction reaction. Let us go for oxidation reduction reaction. Anodic metal gives up electrons where it undergoes oxidation. For example, in case of iron, Fe give rise to Fe2 plus 2 electrons. In cathodic metal, accepts electron, there it undergoes reduction. So copper 2 plus 2 electron give rise to copper. So, in case of gases, a general reduction reaction takes place where 2H plus 2 electron give rise to hydrogen gas. So, let us do what is the effects of corrosion? What are the problems that we are facing in corrosion? For example, loss or economic and safety. For example, reduced strength, downtime of the equipment, escape of fluids, surface properties, reduced value of goods. So these consequences of corrosions may be varied, and the effects these may be safe, reliable, and effect of operation in equipment or structure are more often and serious problems than that of a simple loss of a mass of a metal. So failures of various kinds and need to expensive replacements may occur even though the amount of metal destroyed is quite small. So let us take a practical example. You assume that a underground corrosion, see, buried gas or water pipe can suffer severe corrosion which is not detected until actual leakage occurs. By the time we will detect, the most of the materials considerable damage may be done. Now, in case of electronic components, in electronic equipment, it is important that there should be no raised resistance at low current connections. Corrosion products can cause such damages and have sufficient conductance to cause short circuits. Okay, next, let us consider one more practical example called corrosion at sea. Seawater is highly corrosive and electrolyte towards a mild steel. The ship has suffered severe damage in the area which are most buffeted by the waves, where the protective coating of the paint has been largely removed by mechanical action. Now, corrosion of plastics. So, not only the metals, on other plastics also undergoes corrosion. So, in this, for example, due to internal stress and an aggressive environment, it has suffered environmental stress cracking. When you see this picture, you will be able to understand the plastic material which undergoes a corrosion at a higher level. Now, what are the basics points to be covered in the corrosion part? So, in this case, very important concept is EMF of a cell or EMF of the metal. It is nothing but a potential difference under ideal conditions. So, in case of your electrochemistry concepts, we'll generally discuss about the electrochemical or electro potential values between the reduction potential values. In case of corrosion, we generally discuss about the galvanic series. It is a practical listing, and also a type of galvanic protection also we will discuss in this chapter. Now, before going to this, what are electrochemical cells? Let us have an idea. For example, oxidation and reduction reactions are the general criteria in this concept. For example, the ability to metal to corrode will depend upon the potential difference between the metal and the electrolyte. Obviously, the conducting phase and development of galvanic cells is the primary criterion. For example, magnesium and zinc go in the solution to a greater extent than iron. These metal will have more negative with respect to electrolyte than iron. So here the reduction potential values plays a vital role. In case of nickel, lead, copper go into solution less readily and produce smaller potential difference. The potential difference depends upon the ability of the metal to gain or lose electrons. So let us discuss about this table gives the idea about the how the potential difference between the different types of metals. For example, sodium, magnesium, beryllium, aluminium. For example, in case of aluminium, it undergoes passivation. So when practically with reference to electrochemistry, aluminium reduction potential 1.67, it may undergo reactions, but in case of corrosion, when it will not undergo oxidation, it will undergo passivation. So in this case, zinc, iron, cadmium, these are some of the example. Based on the reduction potential values, this can be determined. Now let us go for the mechanism of corrosion or formation of rust. So in the formation of rust, what exactly happens? You see, consider a iron iron rod or bar which is placed in the surface where it is covered by the environmental aspects such as oxygen, water. So the primary thing is here two types of reactions are possible. One is anodic area, other one is cathodic area. See here iron which is form a primary corrosion product. How the mechanism of the corrosion happens? See, iron it is ready to give the electrons, so it acts as an anodic part. So obviously the environment contains oxygen and the moisture contains water. These react together to give the reaction to form the hydroxyl ion. Once it becomes Fe2 plus and the OH minus ions attract together and it form a primary corrosion product. These primary corrosion products will not stop at the end. So what happens? It will again take the oxygen from the environment and it can go to the secondary corrosion product. See, this is the simple example where how the electrolytic dissociation of solution which happens in the system, where see iron Fe2 plus ion is nothing but you are having iron bar. So these H2O2 and these are from the environment. So this contributes to the OH minus ions. This is anode, this is cathode. The reaction takes place at anode. This is oxidation reaction takes place where iron is ready to give up the two electrons. So this will be taken up by the environment which contains oxygen and water. Obviously it will goes to the OH minus ions. So these two together react together which will form the primary corrosion product. In the presence of again the moist atmosphere and oxygen, it forms the FeOH thrice, or if in the absence of oxygen also it forms a black rust. So this precipitate further initiates the rate of the corrosion. Next, for example, zinc in HCl solution also a similar type of corrosion is taking place. Now you can see what is a type of corrosion. There are many types of corrosion. Let us take a proper example called simple example called galvanic corrosion. This is also called as differential metal corrosion. In this case, required condition: two dissimilar metals are in contact, oxygen dissolved in water. Okay, what happens when two different materials, for example, in case of copper and zinc, are oxygen in the presence of oxygen in water? In this case, when you look at the electrode potential of copper is 1.90 and for zinc is 1.65. Electrons flow from least potential to higher potential. Obviously, copper does not corrode and zinc corrodes at an accelerated pace. And also this practical example we can visualize using the galvanic series concept. So what the galvanic series table says, according to that, so this zinc, when compared to zinc is above compared to copper. So obviously this undergoes oxidation, so it acts as an anode. Obviously it undergoes corrosion. Now look at the galvanic corrosion type, a similar type of corrosion which is happened. A tubing shown here is a part of an aircraft hydraulic system. The material is an aluminum alloy and it's to uh, prevent bimetallic galvanic corrosion due to contact with copper and alloy its retaining nut. This was cadmium plated. The plating was not applied inadequate, so it also severe corrosion. That means a small anodic area, large cathodic area leads to severe type of corrosion. Now similar type of corrosions can be explained another by taking another example. See, for example, a polished aluminum rim was left over with the road salt and mud. So obviously the galvanic corrosion has started between the chromium plated brass and the aluminum rim. So this also a type of corrosion takes place. This is two dissimilar metals. Obviously it undergoes a galvanic type of corrosion. So this galvanic corrosion is quite observed in case of metals which is having two different metals. So which metal is anode, which metal is acts as a cathode, depends upon that the corrosion rate differs. How do you minimize the galvanic corrosion? Obviously, how will you minimize the galvanic corrosion? The use of resistant materials or use of metals which having low electronegativity or similar electronegativity, for example, copper and nickel. So in case of sacrificial anode method, we will use zinc. So for example, in case of this explanation of sacrificial anode method is best example when you are in case of a ship. So for example, it is made up of iron. Obviously, zinc plates are pasted in the ship hulls and body of the ship. So one acts as anode, other acts as a cathode. So the zinc sacrifice itself as anode. So it is called sacrificial anode, where we can minimize the rate of corrosion in case of iron. So use of the transition piece muscle. So we can use the insulating materials or preventing by minimizing oxygen content. This is quite not possible, but this is one of the method. So what are the forms of corrosion? So forms of galvanic corrosion, when two dissimilar metals, so electrolyte, electrical connection, or pitting corrosion, as we explained, localized corrosion from holes or indentions are difficult to, initially it is very difficult to detect this type of corrosion. Now, how will you prevent this corrosion? So there are different types of corrosion which is happened. So we can use many materials where treatment of metal surface coating, or there are many cathodic protection, anodic protection. We can use the paints, organic coatings, metallic coatings. These are phosphating, anodizing. These are the some of the materials we are learning here. Now these materials, what we are posing is generally a basics. So in order to gain more about these concepts, you have to refer any textbooks which is related to this. You'll get a better idea. Okay, thank you for your kind attention.